Module 8, Stoichiometry, Mole Relationships in Chemical Equations. Last module, we talked about how to relate the number of moles of a reactant to the number of moles of a product formed in a chemical reaction. Remember that a chemical equation is a mathematical expression, so whatever you do to one side of the equation, you need to do to the other to make sure they balance. As I mentioned in the introduction, if we consider the production of toy cars, looking at the car bodies and the wheels, we can say that one car body plus 4 wheels equals one complete car, or 2 car bodies plus 8 wheels will produce 2 complete cars. This is like a formation reaction, isn't it? But we can also look at this analogy as a decomposition reaction. What if you have 3 complete cars and your little cousin comes in and breaks them apart? You will have 3 decomposed cars, resulting in 3 car bodies and 12 wheels. And like any mathematical equation, if I were to tell you you had an unknown number of car reactants that decomposed completely into car bodies and wheels, but I told you that you had 8 wheels, you could figure out that you began with 2 complete cars. You could do that because you knew the relationship between car bodies and car wheels. As long as you knew that, you could figure out the relationship between any single product and reactant, couldn't you? Let's look at a chemical equation using these ideas. A chemist forms ammonium sulfate, NH4,2SO4, which is an excellent fertilizer, by combining ammonia, or NH3, and sulfuric acid, H2SO4. If she ends up making 12.2 moles of ammonium sulfate, how many moles of ammonia were used? Well, we first need to know the correct chemical equation. We're given that ammonium sulfate is formed, so it is our product. We are also told that ammonia and sulfuric acid are the reactants. Now we need to balance the equation, but first look at that product. There are lots of subscripts and a set of parentheses. I want to make sure you know what all that means. The parentheses surrounding the NH4 has a subscript 2. That means that there are 2 complete NH4 molecules bonded to the SO4. Whatever atoms are in the parentheses are affected by that 2 outside of them. So to know how many nitrogens are in this molecule, we need to multiply that single atom by 2. There are 2 nitrogens in this molecule. But there are 4 hydrogens within the parentheses, and there are 2 groups of them, so multiplying 2 by 4, we can see that there are 8 hydrogens in this molecule. There is a single sulfur, and there are 4 oxygens too. So be careful to correctly count the atoms whenever you see parentheses. We have the number of atoms on the product side. Let's count the reactant side. There's 1 nitrogen, 5 hydrogens, 1 sulfur, and 4 oxygens. If we add a coefficient of 2 in front of the ammonia molecule, that balances everything. Well, now that we have the chemical, what is our plan of attack? We are given the number of moles of product, and we are asked for the number of moles of ammonia that were used in the reaction. The balanced chemical equation gives us a relationship between these 2 molecules. 2 moles of ammonia equal 1 mole of ammonium sulfate. So we can set up a conversion equation using our given number over 1 and multiply it by the relationship. Canceling out moles of ammonium sulfate, we get 24.4 moles of ammonia as our answer. Can you see that you can figure out quantities of reactants or products as long as you are given one quantity and have a complete balanced chemical equation? It doesn't matter if you are given the reactant quantity or the product quantity. You can use the relationships in the balanced equation to find the quantity of any other unknown item in the reaction. If the problem asked for the number of moles of sulfuric acid that were used, we could easily figure that out too. We still have the number of moles of product. We can find the relationship between the number of moles of ammonium sulfate to the number of moles of sulfuric acid from the equation. Then, set up that relationship to find the number of moles of sulfuric acid used. As long as we have the amount of one substance in the equation, we can use the balanced chemical equation to find its relationship with any of the other substances to find their amounts.